1A and therefore has one valence electron. And because it's in group 1A, it wants to lose its electron. So lithium loses its electron to be stable like helium. And it forms Li plus or lithium ion. And in the Bohr model, lithium plus has no dots in the structure because it gave all of them away. And that goes for the Lewis dot structure as well. It has no valence electrons because it gave them away. Phosphorus is in group 5A and therefore has 5 valence electrons, and it wants to gain electrons. So phosphorus gains electrons to have a stable structure like neon, and that forms P negative 3 or phosphorus ion. So P negative 3 would have 2 valence electrons in its first shell and 8 in the second shell on the Bohr model. And then on the Lewis dot structure, it will have 8 valence electrons. So in order for phosphorus to become phosphorus ion, P negative 3, lithium would have to give away its electrons to phosphorus, and it needs 3 lithium elements in order to have its 8. And then our next elements are sulfur and oxygen. Sulfur is in group 6A and has 6 valence electrons, and it wants to gain electrons. So sulfur gains 2 electrons to be stable like argon, and that forms S negative 2. Sulfur ion or sulfur ion. So it has 2 dots in the first orbital and 8 valence electrons in the second orbital in the Bohr model. And then it has 8 valence electrons on the Lewis dot structure. And then oxygen has 6, it was in group 6A, so it has 6 valence electrons, and it also wants to gain electrons. So oxygen gains electrons to be like neon and have a stable structure, and that forms O plus or oxide. So oxide has 8 valence electrons on the Lewis dot structure and then 8 valence electrons in its last shell on the Bohr model. In order to be stable, one sulfur element will have to give 3 oxygen atoms its 2 valence electrons. So 2 will go to 1, 2 will go to the second one, 2 will go to the third one, and that makes oxygen have 8 valence electrons.